All right, here are solutions for quiz 3 for Math 251. We're given 3 functions here and asked to find some stuff. The first part, we're asked to find f prime of 3 using the difference quotient or the definition of the derivative. Damn, I hate it when I say or because that means I got to do both ways for the solutions. But I guess I can do that. All right, difference quotient tells you that f prime of a is equal to the limit as h approaches 0 of f of a plus h minus f of a divided by h. Definition of the derivative tells you that f prime of a is the limit as x approaches a of f of x minus f of a over x minus a. So okay, one at a time. If I'm going to use the difference quotient, this gives me f prime of a, but I don't want f prime of a, I want f prime of negative 3. So f prime of negative 3 is going to be the limit as h approaches 0 of f of negative 3 plus h minus f of negative 3 divided by h. And I know that f of x is this thing, 2 over x, so f of negative 3 plus h would be 2 divided by negative 3 plus h. F of negative 3 would be 2 divided by negative 3. And that whole thing is over h. Yeah. I don't like having this negative in the denominator. It looks weird to me. You don't have to do this next step, but I'm going to do it. I'm subtracting this fraction that has a negative in the denominator. Really, that's just saying plus 2/3 divided by h. Just because I think that's ugly, I change it to that. Anyways, back to the problem. This is a limit we got to evaluate. You can try changing all the h's to zeros, but you'll get 0 over 0. The same old story that I've said a bunch of times. So what you got to do is figure out a way to get an h out of the top to cancel with this h on the bottom. The trick for doing that, when you have fractions inside of fractions like this, is get a common denominator. The common denominator in this case will be negative 3 plus h times 3. So I got the limit as h approaches 0 of, let's see, if I multiply this side by 3 over 3, I'll get 6 divided by 3 times negative 3 plus h. And if I multiply this side by negative 3 plus h divided by negative 3 plus h, on the top I'll have 2 times negative 3 plus h. And on the bottom I'll have that same denominator, 3 negative 3 plus h. Keep in mind that that's all up in the numerator of your big fraction, which has a denominator of h. So it's still pretty ugly. Hopefully we can clean it up pretty good on this step. I have a common denominator, so I can add these fractions. I can just write that a single time, 3 times negative 3 plus h. And then up top I got 6 plus 2 times negative 3 is negative 6. 6 plus negative 6, that just goes away. Plus 2 times h. I'm left with just a 2h in the numerator. So I boiled it down to this problem. Instead of h in the denominator, I like to think about it as h over 1, because then to me it's more apparent what I do when I'm dividing fractions. It's like multiplying fractions, except I multiply by the reciprocal of the denominator. All I'm saying is flip the thing on the bottom upside down. Instead of h over 1, it's 1 over h. And now you can cancel out these 2 h's and say that this is the limit as h approaches 0 of, I'd have a 2 up on the top, and on the bottom I got 3 times negative 3 plus h. Good news is this is a limit I can evaluate now that I've gotten rid of these h's. Change all the h's into zeros. What you get is 2 divided by 3 times negative 3 plus 0. 3 times negative 3, negative 9. 2 divided by negative 9, in other words, negative 2/9. This right here is my answer. If you don't like that way, you can do the same problem using a different method. Maybe I should switch colors. Or Use the definition of the derivative. I need to know what f of x is, given to me right here. So I need the limit as x approaches a of f of x minus f of a. Oh, that's not what I want. Shoot. I don't want f prime of a. I want f prime of 3. Negative 3 even. F prime of negative 3 is the limit as x approaches negative 3 of f of x minus f of negative 3 divided by x minus negative 3. In other words, x plus 3. All right, and then this is the limit as x approaches negative 3 of f of x is this 2 over x thing that I was talking about. F of negative 3 would be 2 divided by negative 3. So I'd have minus 2 divided by negative 3. In other words, plus 2 over positive 3. Get here? Same issue that we had on the other problem. Try changing all the x's into negative 3's. You'll get 0 over 0. Okay, so if I get a common denominator on the top, 3x would be my common denominator, so let's multiply this by 3 over 3. That gives me 6 over 3x. If I multiply this by x over x, that gives me 2x over 3x. And if I add those two fractions together, I get here. Kind of like I did over here. Now I have a fraction divided by a fraction. I can change that from a division of fractions problem into a multiplication problem. 6 plus 2x over 3x times 1 over x plus 3. And as you might notice, remember it was this x plus 3 that was causing trouble. That's what I'm trying to get rid of. There's an x plus 3 hidden in here. If you factor out a 2 from both of these terms, you're left with x plus 3. I guess 3 plus x, which you can cancel with this guy. So this is the limit as x approaches negative 3 of, do I have to write it twice? I'm going to be lazy. Factor out a 2 here, and then cancel the x plus 3's, and you'll be left with 2 over 3x. This is a limit I can evaluate, change all the x's into negative 3's, and I get 2 over negative 9, in other words, negative 2/9. Same answer I got over here. All right, I don't want these solutions to take a half an hour, so I better hurry up. Or maybe I shouldn't. Find g prime of negative 2 using the definition of the derivative. Fine. Here's the absolute value of x plus 2. So if I'm going to use the definition of the derivative, that tells me that g prime of negative 2 is the limit as x approaches negative 2 of f of x minus f of negative 2 divided by x minus negative 2. In other words, x plus 2. Well, f of x, as we saw up here, g of x, damn, these should all be g's. Great, now the solutions are completely illegible. Can I make an f into a g without completely ruining things? That's not too bad. Anyways, g of x, it's given to me up here. It's the absolute value of x plus 2. Minus g of negative 2 divided by x plus 2. And this is the limit as x approaches negative 2. This mess. Well, negative 2 plus 2 is just 0, and the absolute value of 0 is just 0. So what I get here is the limit as x approaches negative 2 of the absolute value of x plus 2 divided by x plus 2. The way you evaluate this limit is, let's look at anytime you have an absolute value sign, you look at the limit when you come from the right side of that mess, and you look at the limit when you come from the left side of that mess. If I get the same answer here and here, that'll be my answer up here. If I get a different answer, the answer up here is undefined. Well, let's see, when I'm slightly bigger than negative 2, I'm like negative 1.9. Negative 1.9 plus 2 is a positive number. If you have a positive number, the absolute value symbols don't do anything. So I can drop those absolute value symbols because they're not doing anything. Just write x plus 2. So this is the limit as x approaches -2 from the positive side of, these cancel out and just give me 1. The limit as x gets close to -2 of the number 1 is just the number 1. If I do that same logic over here, limit as x approaches -2 from the negative side, so now I'm slightly less than -2, so -2.01. You add 2 to -2.01 and you're still negative. So if we want to get rid of the absolute value symbols, we got to think about what the absolute value symbols do in the case that what's on the inside is negative. And what they do is they flip that sign, they make it a positive. Mathematically, the way you can say they make it a positive is you can say they multiply that quantity by -1. So it's not just x plus 2, it's the negative of that thing because the absolute value symbols switch the sign. Cancel out these x plus 2's just like I did over there, and the limit that I have to evaluate is the limit as x approaches -2 from the negative side of -1, which is just equal to -1. Because we have different limits here, I say that the limit as x approaches -2 is undefined. So that's my answer, is that it's undefined. In case you're wondering, what that means is that if I tried to draw the tangent line to this curve, the one given to me as g of x, at the point where x equals -2, I couldn't do it. There is no tangent line. Kind of weird. I'll show you what that graph looks like and why that's happening at some point. Part C. Wow, this is a long quiz. I better make this like you guys choose 3 of these parts to do or something. Find h prime of a using the difference quotient. All right, the difference quotient tells you that the limit as h approaches, so tells you that h prime of a is equal to the limit as h approaches 0. This is going to look weird, but okay. Instead of f of a plus h, I'm going to do h of a plus h. This h is kind of like the f. Don't confuse this h and this h. And good luck with that. Minus h of a divided by h. This is unfortunate that we're using the letter h, but our function is also h. Oh well. H of x is 2x squared minus x. All right, I guess I'll keep going. So h of a plus h will be 2a plus h squared minus a plus h. All right, I'm just copying this thing, except instead of writing the letter x, I'm writing a plus h. And then from that, I want to subtract h of a, which is just 2a squared minus a. And I want to divide that whole thing by h, and remember that really what I'm figuring out is the limit as h approaches 0 of this thing. I can figure that out. I tried changing all the h's into zeros, and I get 0 over 0 because this h on the bottom is causing trouble. So really I want to change this h on the bottom into, I want to cancel out this h on the bottom. I hope that when I simplify the top and h pops out and I can cancel it with this h. And you'll see it does. A plus h squared is a squared plus 2ah plus h squared. If I multiply that by 2, I get 2a squared plus 4ah plus 2h squared. And then I got minus a plus h minus a minus h minus 2a squared minus a minus 2a squared plus a minus gets distributed and makes that positive divided by h. And again, this is the limit as h approaches 0 of this mess. The nice thing is that a lot of stuff will cancel. Minus a plus a minus 2a squared plus 2a squared. What I'll be left with is 4ah plus 2h squared minus h. I think that's it. I got this guy, and this guy. This and this cancel. This and this cancel. That's divided by h. I can factor an h out from the top because there's an h in all 3 of these terms and be left with 4a plus 2h minus 1 And now I can cancel out these h's and get that my answer is the limit as h approaches 0 of 4a plus 2h minus 1. I can evaluate this limit by changing all the h's into zeros and get 4a minus 1. Find h prime of a using the difference quotient. All right, I just did. Find h prime of a using the definition of the derivative. All right, we're going to do the same thing, except now we're going to switch colors for one thing. We're going to say h prime of a is the limit as x approaches a of f of x, h of x in this case, minus f of a, again h of a in this case, over x minus a. Well, h of x, I know what that is. It is 2x squared minus x. So I can just write, this is the limit as x approaches a of 2x squared minus x minus h of a. Well, this is h of x, so h of a is just like this, except change all the x's into a's. 2a squared minus a. And divide that by x minus a. The little trick that you saw on your perfect problem for this week is that it'll help to group terms. So what I'm saying is we can think about this as the limit as x approaches a of 2x squared minus 2a squared minus x plus a over x minus a. So all I did is I distributed this negative through and then grouped the squared terms and the linear terms together. And the reason why is I'm trying to cancel out this x minus a. And I can do that if I split this up into two fractions. Yeah, okay. So break it up into two fractions like this, and then do some algebra. I want to get an x minus a out of the top here. The limit as x approaches a. Well, let's see, they both have a 2 in common, so I could factor out a 2. And if I did so, I'd be left with x squared minus a squared, which is a difference of squares. So it's x minus a times x plus a. And then on the bottom here, I got an x minus a. And then for this other one, I want to cancel these out. I need to get an x minus a out of the top here. I almost have that already. Things are just off by a negative sign. So I could factor out a negative 1, and then I would be left with x minus a, which I could cancel with this x minus a. So now I cancel out these x minus a's, these x minus a's, and I get that this is the limit as x approaches a of 2x plus a minus 1. This is a limit I can evaluate. Change all the x's into a's, and I get that this is 2a plus a minus 1. A plus a is 2a. 2 times 2a is 4a. So what I get is 4a minus 1, which hopefully is what I got up here. So that's the derivative, 2 different ways to get at it. And that's the end of this very long quiz.